Dispersion of light. Exactly what is dispersion of light? Let's talk about this. Dispersion of light can be understood with the help of prism. Let's say this is a triangular prism and this is a cardboard. In the middle of the cardboard we have made a small hole, and if a narrow beam of white light is made to incident on one of the side of the prism, then what is seen? It separates into 7 different colors. The most deviated color is violet and the least deviated color is red, and there are other colors in between them also. Altogether they are 7. And when the same colored light comes to another end, then what is seen? Refraction takes place from the another side. If we put the screen just behind the prism, then 7 different colored light can be obtained on the screen. This is dispersion of light. Exactly what is happening? The splitting up of this white light into 7 different colored light in the prism is dispersion, and in first surface dispersion took place, but in the second surface refraction took place because the dispersed light is again deviated more and separated more from each other, and when they falls on the screen, then we'll obtain a color band. And this color band is called spectrum. We can remember it like this: VIBGYOR, Vibgyor. V means violet, I means indigo, B means blue, G green, Y yellow, O orange, R red. VIBGYOR. It is the spectrum. Now it's time to define what is dispersion of light and what is a spectrum. Let's talk about this. The process of splitting up white sunlight into 7 different colored light is called dispersion of light. Now what is spectrum? The color band of light of 7 different colors obtained on the screen after the dispersion of light is called spectrum. Now the question comes, why dispersion takes place when light enters into the prism? And this is the dispersion. What is the reason behind this dispersion? We can say this way: velocity of 7 different colored light obtained on white light reduces when it enters into the prism, but the amount of decrease in velocity is different for different colored light. Hence they separate from each other and dispersion occurs. Here the answer is very clear. The velocity of different colored light decreases in different amounts. That's why light separates from each other. I mean to say, colored light separates from each other. But exactly still we have one question: why they separate from each other when they enters into the prism? They have same velocity in vacuum. When they enters into prism, then their velocity decreases in different amounts. What is the reason? Now I want to talk about the reason. This is the diagram what we made just before. Now red is found to be deviated very less, but violet is found to be deviated a lot. The reason is very simple. These different colored lights have different wavelength. Red has maximum wavelength 8 into 10 power minus 7 meter in average, but violet has very less wavelength in comparison with other. It is 4 into 10 power minus 7 meter. If a colored light has more wavelength, then its velocity decreases a little only. But if a colored light has less wavelength, then its velocity decreases a lot. That's why bending of violet is lot, because its velocity is decreased a lot. On the other side, red, its velocity decreased less because its wavelength is more. And this is really the matter related to the wavelength of different colored light. Because of this difference, they separate from each other. At the end, I want to tell you, remember that in first phase of the prism, dispersion takes place, but in second phase, just the refraction takes place. Okay, we'll meet in another class.